Lesson 8-7 notes talks about bivariate data. Bi means two, variate is variable. So we're talking about two different kinds of data in one table, which is called a two-way table. The first question here is an activity we're going to do in class, so we're going to skip that one for now. And we're going to go to example number 1 here. In example number 1, students in a different class were asked the same question about their favorite ice cream flavor. The table below shows the ice cream flavors and the number of students who chose each flavor for that particular class. This table is called a one-way frequency table because it shows the counts of a univariate. The una is 1, so this is a one variable, a categorical variable. So our variable is the ice cream flavor, and underneath is the number of students who chose it. So we can compute the frequency for each ice cream flavor by dividing the count by the total number of observations. So, for example, 11 out of 25 students said chocolate was their favorite ice cream. That is a relative frequency. That's how many chose it. 11 out of 25 is 0.44, which means I just moved the decimal 2 places to the right, and it's 44%. So 44% of the class prefers chocolate over the other flavors. So using the table for question 86, what is the relative frequency for strawberry? Strawberry, there's 4 of them out of 25 total. So if I were to convert that to a decimal, 4 divided by 25, I get 0.16. And I can make that into a percent if I wanted to, 16%. Write a sentence interpreting the relative frequency value in the context of strawberry ice cream preference. 16% of the students prefer strawberry ice cream over, forgot the word ice cream. Strawberry ice cream over vanilla and chocolate. So that's what it tells us. On to example 2 on the next page. The principal also wondered if boys and girls have different favorite ice cream flavors. She decided to redo the survey by taking a random sample of students from the school and recording both their favorite ice cream flavor and their gender, whether they're boys or girls. She asked the following questions: which is your favorite ice cream flavor, chocolate, strawberry, vanilla, and what is your gender, male or female? So now we have 2 different questions being asked, or 2 variables. And the results are shown here. 30 students who prefer chocolate ice cream, 22 are males. 25 students who prefer strawberry, 15 are males. And 27 students who prefer vanilla, 13 are males. So they're recorded in the survey. So we're going to fill in the table down below here. The first question says, can we display this data in a one-way frequency table? We can't do it in a one-way frequency table because there are 2 sets of data. Male or female, that's one that we're asked. And ice cream flavor. So we need a two-way table now for this one. Summarize the results of the second survey in the table below. Let me get rid of this, where the line came from. So we're going to look at chocolate. This is the chocolate column. And 30 students total. 22 are male. That means 30 minus 22, there's 8 females. Now I go to the strawberry. 25 students chose strawberry, and 15 are female. That means there were 10 males. 25 minus 15 is 10. The last one is vanilla. There's 27 total, and 13 are male. That means there were 14 female. So if I add these across the male, 22 and 10, that's 32, and 13 is 45 total males. And I add across for the females, and I get 37, and then together I get 82 students surveyed. Calculate the relative frequency for the table above and write them in the table below. So the relative frequency for males, how many males out of the total chose chocolate? That's 22 out of 82 students, which is approximately 0.27. Males that chose strawberry, that's 10 out of 82, which is 0.12. And how many males chose vanilla? That's 13 out of 82, which is 0.16. So if I add those across, that means 0.55 of the population was male, or 55%. Female, I would do the same thing. 8 out of 82 is approximately 0.10. 15 out of 82, 0.18. So I'm just converting these into a ratio. 14 out of 82, 0.17. That means 0.45, or 45% of the population was females. The total number of students who chose chocolate was 30 out of 82, which is 0.37 approximately. And I keep going across, and I could add the male and female. That's 0.30 and 0.33 and 1.0, because that's the total, which is 100%. So you're calculating relative frequency by finding the ratio or the proportion of how many chose that to the total. Use the relative frequency table to come up with the answers. What is the proportion of the students that prefer chocolate ice cream? So out of the total, how many prefer chocolate ice cream? We came out with 0.37 from the table. 92, what proportion of the students that are female, so female only, and prefer vanilla ice cream? So female and vanilla ice cream, that was the 14 out of 82, which is 0.17. Write a sentence explaining the meaning of the approximate relative frequency 0.55. Relative frequency of 0.55 means approximately 55% of the students surveyed are males. Write a sentence explaining the approximate relative frequency of 0.10. That means approximately 10% of students surveyed are females who prefer, we check our table, chocolate ice cream. So that's just reading what the table shows us. Example 3, we use the total number of students to calculate the relative frequency. Sometimes we can use a row or column to calculate relative frequencies. So these are called row relative frequencies, meaning you're going across and comparing. Column relative frequencies means you're going down the column. So in this case, this is our exact table we used. But we can use it also a different way, going across instead. So we use the total number of students to calculate the relative frequency. This was the survey to the group. Suppose you're interested in the proportion of male students that prefer chocolate ice cream. How is this value different than the proportion of students that are male and prefer chocolate ice cream? So that's different. Proportion of male students or proportion of students that are male is different. So the first one, I'll call this A. Proportion of male students that prefer chocolate ice cream was 22 out of 82, which is 0.27 approximately. And B, students that are male and prefer chocolate ice cream is 22 out of 45. So I'm only looking at the male students and what proportion of them like chocolate ice cream, which is approximately 0.49, which is a different scenario than each other. So you have to be careful of the wording of the question to decide which numbers to use. So 96A, what proportion of students that prefer vanilla ice cream is female? So students that prefer vanilla ice cream, there's 27 of them. And how many are female? That's 14, so it's 14 out of 27, which is approximately 0.52. B, proportion of male students who prefer strawberry ice cream. There's 45 male and 10 of them prefer strawberry. So 10 out of 45 is approximately 0.22. And then it says, write a sentence explaining the meaning of this proportion. 22% of male students surveyed prefer strawberry ice cream. So there's a few questions left here. Hopefully you have an idea of kind of what we're talking about. I'm asking that you try those 4 questions just to see if you can relate to what the table shows and the questions we're talking about. If you have questions or problems, of course, ask during class. We will go over those during class too.